Thank you. Can you hear me well? Okay. So hi everyone. I'm Thiago. Maybe I should continue talking storybooks because I also like it a lot. But unfortunately, it's a little bit more generic topic this time. I'm here to talk about OTA. Due to a lot of investigations, deep work I've been doing in one of our biggest projects at CostTech. So I just figured maybe I'll show out a little bit deeper, hopefully, than what is usually told about OTA, maybe the newer alternatives nowadays, and something at the end that you might not have thought about that you could use as OTA, but is very useful as well. So my name is Thiago. I'm a developer at CostTech. You probably already know that. I'm one of the co-organizers of React Native Porto with Danny. There's my ex if you want to follow. This is a picture without mustache. Maybe I should just ask Gemini to fix it for me. By the way, the title, maybe I should have spent more time on working on the title. It's like over-the-air updates, the modern ways. After the first talk, amazing talk, I was thinking, okay, I'm seeing this in modern ways, but there's nothing with AI in this talk. So if you were looking for AI, then there's nothing AI here. So yeah, let me continue. Just very briefly, I won't bother you like how much on why we need OTA. I'm assuming that you already know what OTA is more or less and how and what do you use it for. But just for the sake of completeness, let's talk about it. So OTA we use to send updates basically without going through the App Store, right? You want to send updates quickly. Maybe it's Christmas time. The App Store reviews, we know that it's much longer. So maybe you want to send updates there. So use OTA, usually do hot fixes, Christmas decorations, or anything that wouldn't change the look and feel of your app too much, because then we know Apple wouldn't like it. And basically we use it to ship daily, right? We use to ship fast and to avoid these long reviews of the app stores. I bet you already know that. But also, when we talk about OTA, if you've been here long enough, sorry. If you've been here long enough, you probably remember Code Push and App Center. That's when you talk about OTA, that's the first thing I remember, but unfortunately is dead. So the modern ways is, we'll talk about it. There's several options you can use based on your requirements, right? But okay, like how does OTA actually work under the hood? So I came up with some drawings that we'll try to go step by step. So you've probably seen a version of this drawing before. So we have our app in the bottom, and we have the server, whatever OTA server you're using in the top. During runtime, when you start your app is going to ask the server, okay, hey, do you have update for me? And the server is going to respond, hey, here's the update for you, if there is an update. Then, of course, if there is a bundle hosted on the server, someone needs to upload it, right? Then we add the third component to this drawing, which is the thing that uploads the bundles to your server, which is your command line or maybe GitHub Actions, any other CI, whatever. So the CI uploads the bundle to the server, and the app communicates with the server. So during runtime, you download the bundle, and then it replaces the bundle. So maybe that's actually the next step. So after we download this bundle, it gets in our device, in our phone, right? So you probably already know that the React Native app is a native app. So we have the native files, the native frameworks, libraries, whatever. And also this JS bundle, which is this big JS file. So let's zoom in a little bit in the app. So when we're downloading the bundle, let's say bundle.zip, because when you upload this bundle, this is probably, depends on your tool of choice, but this is usually compressed as well. Now, when we download this, this has to go to our native module, right? So this makes us think every OTA library needs to have a native module, because you need to download this file. And if we're going to replace the JS bundle for a new version of this JS bundle, our JavaScript thread cannot be interrupted, right? So this is done in the native thread. And then the native side of the library will coordinate how you replace this bundle. So there's two steps for it. The first one is some security checks that we'll go on a little bit deeper in a second. and then you actually replace the bundle. So just a quick recap. So the updates, they are handled by the native side. We do some security checks, and then we replace the bundle. Regarding security, there's those security checks that I mentioned is one part, is this first one, this man-in-the-middle attacks. So there's 3 steps to security, maybe more. I mean, you could find endless steps, but there are 3 main ones. First one is regarding man-in-the-middle attacks, that we use file integrity verification to prevent that. So basically prevent someone from intercepting this bundle when you're downloading from the web and putting something else and getting into your users, and then your user interact with malicious code and lose money, lose a lot of things. The second thing, which is pretty obvious, is like leaking environment variables. Depends a lot on the tools that you're using. For example, this actually something that I saw in the hot updater docs, which is one of the OTA tools. They mentioned if you use React Native .env, for example, even though you're not using those secrets that you used to deploy, you're not using in runtime, they might still be exposed in your final bundle. So that's something we gotta care about as well. And then final thing I brought is MTLS, which is basically mutual to LS, which is a way to prevent. It's more like a server thing. It's not a client thing, but it's basically you wanting to prevent that someone reaches your OTA server directly to download your bundle without going through your app, right? It's nothing like it's not us trying to prevent someone from accessing the bundle, because they can always use the app, reverse engineer the app, which is in their phone. They can just decompile it and find the bundle as well. But this is more of a way of you trying to save costs. For example, if you're self-hosting OTA, then you can prevent a lot of people trying to access your servers, and you just prevent network traffic and you save costs. Then we come again to this graph. So now that we talked about security checks, and I talked about man-in-the-middle attacks and consequently file integrity verification, how does file integrity verification actually work? So when we're uploading the bundle to the server, we're actually uploading a hash as well. So when we're deploying our bundle, when we're generating that bundle, actually building, we calculate a hash like SHA-256, for example, and you upload this hash of the bundle to your server as well as metadata. And then when you download this bundle, so this is the security check. Before you apply this bundle, you recalculate the hash and see if the hash is the same as what you deployed in the secure way when you're deploying in your CI, right? And that's basically how you prevent someone to tampering or like intercepting your connection and replacing the bundle with some malicious code. And then you can replace your bundle safely. So this is the recap. So when you upload the bundle, we hash. So the contents of the bundle, we hash it, because if anything changes, the hash will change. And then before applying the bundle, we also check the hash locally. So you should check your library and server support, because this depends on which library you're using. For example, if you're using Expo updates, of course, this is already handled for you. If you're using hot updater, this is also handled for you. But if you're using any other options, I didn't investigate all of them, but you should go and check if this is happening, especially if you're self-hosting. Because if you're paying for the hosting, like one of those companies that provide the hosting for you, you just use their servers and they host your bundles for you. This is most probably already done. But if you're self-hosting, it's especially good that you check it. So how is the bundle actually loaded, right? I told you that we download in the native side and then we load it in the JS side. So hopefully you already saw these pieces of code of Android, and later I'll show iOS as well. So this is just like the main application. So probably the entry point of your Android app. So you might recognize this. This is not even from the latest version. So from, I think, React Native 82, this already changed a little bit, but I decided to bring this up because this should be more recognizable for everyone. So this is the main application. If you go a little bit down, you find this fill of these flags that you can always use to customize some stuff. For example, use developer support you can use to decide whether you're loading the bundle from Metro or not. Then, for example, you can even turn on and off new architecture, Hermes, etc. All that stuff that you might already have seen. One special flag, which is called very conveniently get.js bundle file. And if on Android, if you don't provide this function, it will load from the default location, which is in the Android assets. But then you have the option of providing it and overriding it. This is an example from Hot Updater, because this is the library that I've been using lately, just because it makes sense for my set of requirements, right? Doesn't mean it's better or worse than others. But I also like it because it's a pretty new code base and simpler than others. And for the sake of showing here, it's way simpler to show. Like it's literally, this was literally taken from their docs. So this is on Android. So how about iOS? So you've probably seen that as well. The app delegate, I just put some unwanted text here. But then in the end of the app delegate, you also have this same bundle URL function. And it acts the same way. This is the default that comes with your React Native app. It's basically saying, if it's debug, you get from RCT bundle URL provider, which is basically gonna pick up from Metro. And if it's not debug, it means it's release. So it's gonna take from the main bundle of your iOS app, and you can see it's called main.js bundle. So here, basically what we need to do is just replace this for your library bundle loading function as well. This function, and this should work very much the same on all of the libraries, is this function will, if you have a cached downloaded bundle, it will load that one. Otherwise, it will fall back to the embedded in your app as well. So basically, your app ships with one JS bundle, you download another one, and you keep both, right? You have one cached and one embedded. If your cached one ever fails for some reason, you still have the embedded that you can fall back to. So this is just a quick explanation about how you load the bundles. And you might also ask, depending on what kind of project you are, maybe you have a very complex project like a brownfield project. And if you don't know, brownfield project, they are very popular, I think, in the last few years. We've been doing a lot of those at Callstack. And well, if you don't know, brownfield project is basically you have a long-running native project, native iOS, native Android, and now the client says, okay, we need to develop faster. Let's migrate to React Native. What happens is that these companies are not gonna, especially if you have big companies or big apps with too many features, you're not gonna have a big brain approach like, okay, let's start from fresh from React Native now, while we still maintain the old one. This usually doesn't happen. It's just not cost efficient for companies. So there you have brownfield, which is you mix and match both of them. You have actually several entry points for React Native inside a native app. Like maybe you enter one tab is native, you enter another is React Native, another is native again. So you never know. So what about brownfield? That's actually nothing. It just works. So if you just use those methods, it should just work, because in a native project you have all the control of the native functions as well. So you can just do the same as I was saying before, and it will just work. I just included here because sometimes people wonder, like, okay, how do you do OTA? Like, do you need to do anything specific? Actually not. Actually not. So, but there are some modern features you should consider that maybe they didn't exist before, or most specifically, if you are self-hosting, and again, you're probably if you're self-hosting, and it's probably because you work in a big enterprise or your client is a big enterprise, they cannot host the bundles on some of these third-party servers because of security compliance, and then you go into the deep rabbit hole of self-hosting and having to do some of these things manually. So some modern features you should consider if you're doing OTA. One very fresh, actually, at least fresh on Expo, which is what makes us all use the new features, is bytecode diffing. So again, I come back with this drawing, and bytecode diffing basically works the way that instead of always downloading a full bundle. Let's say you did a small fix, but you still need to download the full bundle. It's very obvious now that I say you just try to do a binary bytecode diff of the change, and you just download this patch, and then you apply the patch, which would be like a few kilobytes instead of maybe 20 megabytes of JS bundle. So coming back to this drawing, the thing that will change here is that after you upload the bundle to your server will calculate this diff between the previous bundle and the new one. And when we download it, so we go back here, instead of downloading the bundle, you download the diff. And instead of replacing the JS bundle, you apply the diff. So it's pretty obvious, actually. There are libraries that facilitate this for you. For example, most of the libraries that do bytecode diffing, they use this tool called BSDiff. So it should be somewhat reasonable for you to implement yourself as well if you need. The second modern feature that I would recommend is a fingerprint matching. And fingerprint matching is basically, well, you're going to say now that everything I'm talking about is by calculating hashes, but this is actually how most of these things work. And fingerprint matching is basically, instead of you saying that, okay, for app version 1.2, this is OTA 1 that works. Now you deploy a new version, you need to deploy a new OTA. Fingerprint matching basically says that you take a fingerprint of your native source code. So actually a hash again. So you hash your native source code, and then you have a fingerprint, right? And then when you're uploading your OTA bundle, you say this bundle is compatible with this fingerprint. So as long as your native files don't change, your bundles will continue to be working in these old versions. So you can actually, it's a bit easier after you get into the process, it's a bit easier to manage these updates. And also it makes you target more users, because sometimes when you need to, if you're just doing app version, you need to be a lot careful. Like, hey, you need to ask your developers, hey, did you change anything on the native side that we can deploy this OTA or not? This way, you'll never guess, because the native files speak for you as long as you configure them correctly to say these are the relevant native files that if they change, everything's going to break. So that's more or less the idea. So for example, and then in your server, your app has the fingerprint inside the app. So he reaches out to the server and says, hey, get me the update that is the latest update that is compatible with my fingerprint. So this is very cool. I know it exists on the Expo updates as well, and Hot Updater as well. Probably others, but I didn't go so deep into others. So just a recap, bytecode diffing. So the CI uploads the bundle, the server calculates the diff, the client downloads only the diff, and then the client applies the diff. This is very cool because this is actually available in the latest Expo SDK that I think it's in beta. So they are announced very recently. So if you're using Expo, you should probably go try it out. And I already know in the 56, so the next one, they already said it's going to be the default. So it must be pretty stable. For fingerprint matching, if you need to know, then when deploying App Store version, so when you deploy the App Store version, you embed the hash of the native files, so the fingerprint. When deploying the OTA, you calculate this hash again. And when the client downloads, you check if the hashes match. And as I said before, multiple App Store versions can download the same as OTA as long as the native files don't change. But okay, all that said, do I have time? Okay, a little bit. All that said, what if we could do some kind of mini OTAs? So here is just some food for thought. This is not really, it's not really an OTA solution, but it can act like it. And if you have other requirements that fit it, you would probably make good use of it. So what if mini OTAs? So going back to our drawing of the native app. So we have our native modules and we have our JS bundle. What if our JS bundle is not one big JS bundle, but it's several small JS bundles. If you come from the web, if you did web, you probably know that I'm talking about module federation, and then you split your bundle into several chunks. And that's exactly what this is. You have one big JS file separated into several small modular logical components, not components, but chunks, which you divide however you want. So for example, maybe I have one big module that is my auth authentication module. I have another one that is the payments module and X other amounts of features. If you know where I'm going, it's basically I'm saying that these chunks, they are loaded remotely if you use module federation. So for example, you can load the authentication module from one server, the payments from another, feature X from another server. So since they're loading remotely in runtime, as long as your server changes whatever is hosting, you change whatever you're downloading, and you change whatever is showing for your user, right? So this is not a module federation talk, but module federation is a big topic. If it fits your needs, you probably already know. If you don't know what I'm talking about, you probably don't need it. It's a lot of complexity, but if you're already on the track to use it, then you know that you can use this as some kind of mini OTA, because then you can upload some independent modules via updating the bundle in this server, which is very similar to OTA. But then this on its own doesn't solve all OTA problems, because you still have, let's say, everything around these modules is still the shell of your app, right? So you still need a general solution OTA library to handle the other parts, maybe your bottom tabs, your header, this kind of stuff. That is not going to be your modules. So this is basically me saying that if you have these requirements, the way you do module federation on React Native is through Repack. Repack is developed by Callstack, by one of my friends. And it's a very, very nice tool. But Repack is a solution to team problems, to organization problems, rather than a technical solution. You should go for module federation when you want to ship independent. Teams need to move independently and move fast, rather than one team moving all together. So yeah, go check out Repack if you feel like it would help you. And one quick recap is Repack, to be perfectly clear, is an alternate bundler to Metro. So just to be very clear, there is a cost of changing bundlers. There is always a cost, especially since Metro is so much tied to React Native itself. So you go through some bumps, but we believe that these days it's pretty smooth, that you can try. So Repack is an alternate bundler to Metro. Module federation allows you to load chunks remotely. The remote server defines which chunk will be downloaded, and this can act similar to OTA. But there are trade-offs. If you need module federation, you probably know. So conclusion and some maybe alternatives. Code push is dead. It's been a long time. There are some other options that you might have heard. And which one should you choose? I don't know. It depends on your requirements, because each of them, they have their own strengths. It really depends on your project. So for example, is your project Expo? Then it's very easy to recommend Expo updates, right? It works very well. Even if you don't want to use EAS, which is their paid server cloud, they still provide you with the open protocol and open source implementation of the server, so you can still self-host it. We have apps in clients that use self-hosted version with the Expo updates client library, and it works very well. But maybe you have like a long-running app that was using code push, and you just want like the least effort to migrate. There's these services like Revo Push and Code Magic, which, as far as my knowledge goes, they took code push, the deprecated open source library, they forked it, added support for new architecture, they host a server for you, and then you pay the price, right? So it's perfectly fine as well if that's the requirement that you're going for. Or maybe you're using Azure, because Code Push, we know that it was very much tied to Azure. So if that is your requirement, that is fine as well. Or maybe you could go for the young, broader hot updater, which is, in my vision, easier to self-host. They have a lot of options. You can self-host on Lambda, Supabase, your own server, whatever. It's infra-agnostic, and it's actually the only one that has documented repack support. So if you need both module federation and OTA, that's why I'm giving this talk, because that's what the solution that we ended up on. So choose wisely. And thank you very much. That's it.
Nice. Questions?
So first of all, very good presentation. I really like it. About this defer feature that you were talking about, that you can upload only like a specific chunk of JavaScript just to patch the bundle. I think it also can decrease like a lot of, and save a lot of money, because some like Expo updates is charging for, actually they are charging for the monthly users, I think monthly active users, but maybe the other tools, they are charging for only for the data usage. So maybe it can decrease a lot, because I think like for us, the updates were always like few megabytes. So
yeah,
it can be very expensive if you have a lot of users. So that's my thought, that it's really nice. But the question is, if you are using this, have you used those over-there updates for the like a huge app with a lot of users? And how do you perform those updates? Like, do you do it on the pipeline? Because you can easily mess up. For example, you are tired, you are go to the wrong branch, and you do an update, and you break something. Do you have a process like for a big apps, how to make it properly?
Yeah, I guess it always depends on the client or company that you're working on. In our case, is a very big app with 5 million users. So definitely I even to implement, I didn't even have the AWS permissions. Okay, so like everything goes through the CI for sure. Yeah, so we have like GitHub Actions workflows that will generate the fingerprint, then you generate the build. After you upload the build, you have a separate one to generate to deploy the OTA. All the secrets are managed inside CI. You barely see it. Yeah.
Yeah, cool. And last question from me. For the Expo update, no, for the Ries pack you mentioned, do you know any app, like a big app, which changed Metro, which replaced Metro with Repack?
If I'm not mistaken, there is Expensify, which they are always in the conference, etc. They're very big. I think one of the biggest open source React Native apps. They're fintech in the US. I'm not totally sure, but I believe they changed. Yeah, they're using Repack. Okay. So they're a fintech in the US. They have like chat-based sending money, that kind of stuff. Yeah.
I think Repack is doing like also better free shaking, right? That they so it also can decrease the bundle size of the app. So
yeah.
Actually, I was thinking about that, but for me it was just I have never heard about the company which made it for a lot of users, for the big app.
Yeah.
So yeah, I'm curious about the examples.
Yeah. We have more. I don't personally work on Repack, so I kind of forgot now. So maybe I can take a look later, and I'll tell you later. Yeah. But yeah, like Repack is based on RSPack, which, if you also do web, is one of the hottest bundlers on web these days. They're very performant on Rust, and it's compatible with the whole Webpack ecosystem. So you can use the Webpack plugins, all that stuff, and you also get better tree shaking and some other performance features, that kind of stuff.
Yeah, thank you very much.
Thank you very much.
So the talks are over, the food is not. So I invite everyone to go out there and grab a bite. Questions to Thiago, Daniela, or Ricardo, you can do it on the networking zone. If you want to know more about Blip, you can also talk with a lot of clippers that I can see here. And I think, yeah, thank you for coming. And not sure if you would say anything else.
Yeah, just thank you for coming, everyone. Thank you, Blip, one more time. Thank you, Daniela, Ricardo, again for the talk. Thank you, Danny. Thank you, everyone, for coming. Again, we didn't expect so many people this first time. So glad to see you all, to meet you all, and we can talk more there while we grab something to eat. Thank you very much.